Hello everyone, welcome to Chemspires. In this video, we'll look into the NCERT Chemistry textbook Unit 2 book back exercises. If you look into the question 2.2 subdivision 1, it asks us to calculate the total number of electrons present in 1 mole of methane. So, the molecular formula of methane is CH4. So from this we can tell that carbon has 6 electrons and hydrogen has 1 electron each. So 4 hydrogens are there. So 4 electrons. So totally in one methane there are 10 electrons. If one molecule of methane has 10 electrons, how much will be there in 1 mole of methane? You just need to multiply by 1 mole. So first we'll write 1 molecule of CH4 has 10 electrons. So then 1 mole of CH4 has 10 into 1 mole. So it will be equal to, what is the value of 1 mole? 1 mole can be written as Na, which is Avogadro number, into 10 electrons. So value of Na is 6.023 into 10 power 23 electrons into 10 electrons. So on multiplying, we'll get 6.023 into 10 power 24 electrons. In question number 2.2, second subdivision, we are asked to calculate total number and mass of neutrons in 7 milligrams of 14C and assume that the mass of neutron is this much. So we have to calculate total number as well as total mass of neutrons present in 7 milligrams of 14C. So write subdivision A. So 14C. So 14C is nothing but 14C. It is carbon and it has 6 electrons. We know that carbon has 6 electrons. So neutrons will be mass number minus atomic number, that is 14 minus 6, which is 8. So we have calculated neutron in one molecule. And molar mass of 14C will be equal to 14U, or atomic mass unit, or grams. Okay, now 1 mole of 14C has how much of grams? 14 grams. So 1 mole of 14C has 14 grams. You should know that 1 mole of anything will be the molar mass. That's why I have written 14 grams here. And 1 mole of 14C has 8 into 6.023 into 10 power 23 neutrons. Let it be there. Let's come to this equation. Just write the reverse of this equation. So 14 grams is present in 1 mole of 14C. So I have written arrow. You can just write in words also. It's not a problem. And in the place of 1 mole of 14C, let's replace it by 8 into 6.023 into 10 power 23 mole, because this much moles of neutron is present in 1 mole of 14C. That's why we are replacing it. And since 14 gram is this much, let's write 1 gram. 1 gram if we have to write, we should bring the 14 to the right hand side denominator. So we get this much neutrons. So 1 gram is this much neutrons. We should know that 1 gram is 1000 milligrams. So in the place of 1 gram, let's write 1000 milligrams. So 1000 milligrams will contain 8 into 6.023 by 14 into 10 power 23 neutrons. If 1000 milligrams has this much, then 1 milligram will be how much? Bring the 1000 to the right hand side denominator. So we'll get 1000 into 14 into 10 power 23 neutrons. So we have calculated for 1 milligram, but in the question they have asked to calculate for 7 milligrams. So let's calculate for 7 milligrams. So if 1 milligram has this much neutrons, then 7 milligrams will be nothing but just multiply 7 with this whole lot of term. 7 into 8 into 6.023 into 1000 into 14 into 10 power 23. We are not multiplying in each step because at the last we have to anyway multiply. That's why I have kept all terms as such, and now at the last we can multiply. So we'll get 24.092 into 10 power 23. minus 3 is equal to 24.092 into 10 power 23 minus 3 is 20. So this is the answer. So this much neutrons are present in 7 milligrams of 14C. Now we have calculated the number of neutrons. Now let's calculate the total mass, which is given in the subdivision B. So we know this much neutrons is present in 7 milligrams. Now let's mass of 1 neutron. Mass of 1 neutron is given in the question as 1.675 into 10 power minus 27 kilograms. So mass of one single neutron is this much kilograms. So we have 24.092 into 10 power 20 neutrons with us in this 7 milligrams sample. So let's write mass of 24.092 into 10 power 20 neutron will be nothing but just multiply this number with the mass of 1 neutron, that is 1.675 into 10 power minus 27 kilograms. So you'll get on multiplication for 0.35 into 10 power 20 minus 27, which is 10 power minus 7 kilograms. The next question is to calculate the same total number and mass of protons in 34 milligrams of ammonia. So let's write the subdivision A. So ammonia is nothing but NH3. So let's write NH3, and we should know one thing before. So in any atom, number of protons will be equal to number of electrons. So we know the electron count for nitrogen and hydrogen. From this we can know the number of protons. So number of electrons in nitrogen is 7, and for hydrogen each is 1, and there are 3 hydrogens, so totally 7 plus 3 is 10. So number of protons in ammonia, that is one molecule of ammonia, is 10. Then the number of protons in 1 mole of ammonia will be nothing but, so 1 mole of ammonia will be nothing but 10 into 1 mole. 1 mole is Avogadro number. So let it be this side. Let's come to our main part. So let's start writing. So mass of 1 mole of ammonia will be, that is 1 mole of ammonia's mass is 17 grams. This is the molar mass of ammonia. So molar mass is nothing but the mass of 1 mole of any substance. So let's write this equation in the reverse form. So 17 grams is the mass of 1 mole of ammonia. So we should find for 34 milligrams. So let's work out step by step. So if 17 grams corresponds to 1 mole of ammonia, so we have already found that 1 mole of ammonia has 10 into Avogadro number of protons. So in the place of 1 mole of ammonia, just replace by 10 into Avogadro number of protons. So 17 grams will have 10 into Avogadro number, that is 10 into Na protons. So 1 gram will have, take 17 to the right hand side denominator, so 10 Na divided by 17 protons. So we have already seen that 1 gram is nothing but 1000 milligrams. So 1000 milligrams will correspond to the same 10 into Na divided by 17 protons. So take this 1000 to the right hand side denominator. So 1 milligram will correspond to 10 into Na divided by 1000 into 17. So 17 into 1000 protons. So in the question they have asked to calculate for 34 milligrams of ammonia. So let's write 34 milligrams of ammonia will correspond to 34 into the already present one, that is 10 into Avogadro numbers divided by 17 into 1000 protons. This is Avogadro number is nothing but 6.023 into 10 power 23. So let's write, and now let's calculate this by multiplying all the terms. So the answer we will get is 120.46 into 10 power 23, and there is 10 power 3 in the denominator, taking it up 10 power minus 3. So 120.46 into 10 power 20, taking the decimal point 2 points to the left, we get 1.20. 46, or we can write it as 5 because approximating. And since we have taken 2 steps to the left, we should increase the number by 2, so 10 power 22 protons. In the subdivision B, they have asked to calculate the mass of the protons in 34 milligrams. So mass of one proton is 1.67 into 10 power minus 27 kilograms. Then mass of this much proton will be 1.67 into 10 power minus 27 into 1.205 into 10 power 22 that we have calculated. So the answer of this multiplication will be 2.01 into 10 power minus 5 kilograms. And this will not change if the temperature and pressure are changed because mass is constant throughout.